Everyone. Welcome to 3D Printing News Unpeeled, live with yours Peels. And well, I hope you enjoyed the 6 news items we have today in the day's 3D printing and additive manufacturing news roundup for today. On number 6, we've got New Forge and the University of Western Australia. They're working together on a 360-degree submersible camera. It's called the Mantis camera. It's used to explore the Ningaloo Reef in Western Australia. What the camera is, you can see this in the next picture, is it's a camera frame, and inside the idea is to have a 360-degree view while the camera is lowered into the ocean. So they'd wanted the structure to be very, very strong, of course, but at the same time not obscure the ports for the camera. And they turned to Newforge, which is an engineering firm, and they made integrated eyelets, integrating the fasteners and all this into the camera. They made a battery holder, and they made it so that the frame is very strong, but it avoids the camera. They used Markforged X7 3D printers and a Markforged nylon, Kevlar reinforced nylon material for that. It took them 2 weeks to design and make this thing. And well, what I like about this is that this kind of thing looks very niche. But I keep seeing ROVs, submersibles, underwater applications, things for divers, things for underwater exploration, things for very technical underwater diving and stuff. I keep seeing this stuff pop up. So this could be a better market than we maybe have anticipated. At the same time, this is kind of a shape that where it really lends itself really well to the Markforged process, but it's not a typical shape we would associate with 3D printing, or we would automatically turn to 3D printing to make it. So this is, I think I like the fact that we're making a shape that's kind of maybe not, it doesn't look like a very lattice structure kind of thing. It looks very, very kind of like it could be injection molded, but still for this kind of application, it's a good design. And the other thing I love about this is that the University of Western Australia, they just wanted a better camera. That's it. They don't want to learn how to 3D print. They don't want to have printers in-house. They needed an engineering firm that could just make this for them, right? They didn't want to learn anything. They just wanted a part. And I think there's too few companies out there that understand engineering and understand 3D printing and are able to cater to companies and take them on this journey into 3D printing without the company taking 6 months and God knows how much time and money to learn all about it. I think that really would be a, a real accelerator to the rest of the market, and at the same time, also be a real enabler to the rest of the market as well. And again, yeah, this application is much bigger than we think for ROVs and underwater cameras and stuff like this. Another example of somebody helping a firm adopt 3D printing is the 5th news item. This is from Lufthansa Technik. Lufthansa Technik is one of the largest builders of aircraft interiors in the world. They also do maintenance for Lufthansa and other people, one of the most well-regarded aircraft maintenance organizations in the world. And you could just go there for your complete aircraft interior. Essentially, you buy the airplane is from Boeing and then or Airbus, and you just buy the fuselage and a lot of stuff, and then you buy the airplane or the engine separately from GE or Rolls-Royce, and then your interior you would buy entirely from Lufthansa Technik. So what they were doing is they were developing a thing called the guide U strips. It's these lighting strips that are an emergency lighting and also an exit lighting strip that you can use. If it's dark in the plane, you can use it to find the bathroom, and if there's an emergency and crisis, you can use it to find your exit. They had a new design. This is called Guide U. And for this typical design, they wanted to extrude a material through a nozzle to make these strips. They were doing a lot of iterations and a lot of different versions of these. So initially they turned to 3D printing to make them. Now, in this case, they worked with a company called Myprintoo. Myprintoo is it's a reseller organization. And again, they gave them advice. They gave Lufthansa Technik advice that, okay, given what you need, you do use this clear Formlabs resin. Now, this is important in the beginning because they wanted to see how the material was coming through these nozzles and to see if when they were blocked and stuff like this. The Formlabs printer was also accessible, of course. They used a 3L printer, which is kind of more on the topper range of Formlabs, but it wasn't a giant 3D Systems industrial system that they turned to. And Myprintoo was able to give them advice to give them the place they need to be at, let's say, to make these things worthwhile. Now, they found out that first it was just for the prototypes. Later on, they decided to go into production to accelerate their time to market. And they saved about 80% of the cost of getting a mold. Now, Lufthansa Technik says that at one point maybe it'll it'll produces parts in in a higher volume, and then of course molding will be an alternative. But in this case, for they're trying to market acceleration, this really made a lot of sense. So we always focus on end use parts, and this is an example of they didn't own the printers, they didn't want to own the printers, they just needed somebody to make them the nozzle and tell them which material and printer to use. And this is not an end use part. This is an intermediate. This is not an intermediate even. This is just some kind of tooling thing. And when we talk about tooling, we're always talking about injection molding tooling, but there's so much out there. And I think nozzles is a fantastic example of something that we should 3D print more of because of the complex nature of it and the shape we can get. You can see these are quite fine parts. Imagine trying to machine these and make these. It's going to be really expensive to make this kind of particular part out of a non 3D printing technology. So I love this idea. Again, these both are, I think, really solid examples of the need for outsourced engineering requirements for 3D printing. The next thing is more of an opportunity that I've been noticing. So this is a company called Heart Aerospace, and they make electric aircraft, or they're trying to make electric aircraft. This gives a huge disruption potentially to the aviation market. And this is a Swedish startup, and they're trying to make a 30-person passenger aircraft. Initially, it'll have a 200-kilometer range. Later on, they want to make a 400-kilometer one. And what is, I think, something to pay attention to is the fact that they expect that as batteries improve, they'll be able to kind of swap out the batteries and improve the range of the aircraft. And their further newer models will also have better range. So that's something that could give this kind of thing, guys, a performance boost initially. They hope to get this thing flying around 2028. And they say now that they hope they're getting lower cost overall, lower maintenance cost, potentially lower seat mile cost, and lower cost in because they operate a battery operated aircraft. Now, of course, this is going to be a huge path for them to get there. The certification, all this kind of stuff for battery for passenger aircraft is of course very, very stringent, very, very difficult. So, and I think regulators are going to be healthily skeptical against all these new technologies as opposed to the older ones they're more used to. So it's going to take a while, but we're seeing disruption in this market. So not only by electric, but also just generally companies like Hermes and Boom Supersonic, where they're disrupting existing players like Boeing and Airbus. And that could be a huge for 3D printing. In the case of Boom and Hermes, Velo 3D and then Velo and Stratasys, respectively, managed to engage these startups very early in the process, help them through their iteration, and help them through their developing of the initial prototypes. And now they're probably going to get spec'd and used for the aircraft. So I think it should be top of mind for 3D printing OEMs or service companies to work with these aviation firms, these new aviation firms. We've seen that we've completely dominated the propulsion supply chain for new aerospace firms, commercial aerospace, and there's no reason why we couldn't do that for a lot of components on board these new electric and new kind of disruptive aviation companies. And especially since they're going to burn a lot of money, we can help them burn less. They want specific geometries. They want to reduce components, part count. They want to reduce weight. It's ideal for us. So, and I think if you get to talking to these companies now, the volume will not be considerable. But if you're just their partner and you get specced for this, then for 20, 30 years, you're making parts of this aircraft. So it could be very advantageous if they're successful, of course. And another thing is like Sweden has, of course, with Saab and other more military type companies, it has an aviation supply chain to a certain extent. But think of a company like this, it could create its own supply chain. If they're successful, there's all of a sudden in Sweden going to be a bigger market for electronics harnesses for aircraft, for control systems, for all sorts of paint and other kind of markets. So this could be a considerable, yes, it's high risk, high return, but it could be the effects on the local economy of having these businesses there could be considerable. The next thing is CAV or KAV, which is a helmet company that got started on Kickstarter. They are using FDM 3D printers, material extrusion 3D printers, and kind of short carbon fiber to make helmets. These are $329 helmets. So think about using a desktop type FDM type system to print this helmet. And that's going to be a very profitable item, I can tell you. One part is their customized fit. The other part is generally the case for using 3D printed helmets is that you can optimize the design in a way that foam can't. So you can make the design so that it can really withstand very quick, sharp impacts. Let's say your head hits a curb, or uh, slower but kind of like very forceful impacts. You fall down with the helmet, but then on a flatter surface, but then slower. So these types of impacts for both of those, the 3D printed helmet could ultimately mitigate them. Um, what Cav wants to do is open their own factory, and they're expanding their own factory to do production in Redwood City. We see that a lot in these, especially kind of West Coast startups. They really want to get it into the production game. Now, for a lot of them, it doesn't actually really make sense. It's kind of stupid that they're doing it. But in this case, given the high margins involved, the idea of them having their own factory and they want a solar powered factory and they want to control this, it might be very advantageous. But for us, it's something we should follow. Like, to what extent does it matter for these guys? When should they buy their own, let's say, HP or AOS machines? Right? At what point should they make their own FDM printers, or what point should they just buy the bog standard ones? Or at what point should they just develop their specific 3D printing technology specifically for a helmet? Think of a particular printer that's only going to print a particular shape of helmet, a particular size of helmet, day in, day out. It's not going to ever print another shape. So at what point would it make sense for these guys to make a specific design from the ground up just to print helmets? That could have huge effects if we're both doing a helmet, 3D printed helmet startup. You outsource to a service bureau in the beginning, you're going to be much faster. Right? You're going to have a much more expensive helmet, but you're going to be much faster, and you're going to be scaling much faster. Right? Me, if I'm going to be printing it at house, I'm going to be able to get started cheaper. I'm going to make my iterations faster, but it's going to take a while for me to scale up. But once I do, I'm going to be making these helmets at a lot lower cost than you do. In the middle, there's kind of an alternative of me kind of buying a machine and you outsourcing it. That's going to really affect how we spend our money and how we spend our days, right? So, and there's no correct choice, because I think it does depend on your market and the type of business and the type of product. But in this case, one could really imagine that you would always outsource, and then I would, for example, make them on a desktop printer first, then outsource, then buy an industrial machine, and then later on develop my own 3D printing technology, depending on the volume as the volume fits it. Now, that could be a very optimal type of scenario. But imagine also the cost of this item if you were to order it from a service bureau, or just the cost if you would make this item on your own using a short carbon fiber kind of filament in your own desktop printer. That's going to be a huge gulf there. So if you can get away with, if you will, if you can use this technology, that's a huge win for these guys. So I think one would expect a lot more helmet companies specifically in 3D printing, and there are several out there already. But I would also expect a lot more sportswear companies. And this kind of idea is when to outsource and when to produce yourself is still going to be a very big thing going forward. The next thing is a company called Tapmaster Incorporated. They are a Canadian, Calgary, Canada-based company that makes hands-free faucets. So think like a pedal faucet, you step on it and then it runs, or like a sensor faucet. And they have bought a desktop metal binder jet, a shop system, and they're going to use that to make valves. And there's two reasons I love this, and three reasons really. One is that these guys have a heart for, like, they really are passionate about making things themselves and making it in Calgary and in supporting that ecosystem. And that means that what they want to do is they want to take the system and they want to kind of get access capacity on the system and sell it to their local entrepreneurs. Now, a lot of people have been trying to start up this and try to get this access capacity and monetize it in some way. It's never worked so far. But of course, think about the potential, think about the financial potential of this for both this Tapmaster company and other people. Think of just how much excess capacity there is, and think about how much Tapmaster could reduce the cost and reduce the cost of its components by just taking other people's components, kind of Amazon AWS way, and processing them also. At the moment, they just have one system. They're running 316L on it. They've got a Haas CNC on it as well. And they think that for their valve application, they're going to have very little processing, and they can do a quite a quick turnaround time for a local company. That's going to be a bit difficult, of course, given the design constraints of BinderJet. But I think this could be a trend that a lot of other businesses do as well to strengthen their local ecosystems. On the other way, why I think this is significant is the fact that they're doing valves, and valves is again we know we can get there cost-wise. We know we can do for the high-end valves in powder bed fusion and BinderJet. We know we can get the performance, and we know there's a lot of valves out there that could be benefit from being 3D printed, and be made lighter or higher performance or that kind of thing. So I really, really, really like this. The number one news item is a rather surprising one, I think. It took me by surprise anyway, and it's Roland DG, which is a huge Japanese company that makes all sorts of inkjet systems and textile print systems and milling and all sorts of systems. They make dental. They have dental 3D printers, and they have another 3D printer as well. And they make thousands and thousands of these kind of milling type systems a year. And they are setting up a binder jet joint venture. I would not have expected that to happen, essentially. So Roland is actually going to be taking 5% of this joint venture. The other two companies are MSki and AGC Ceramics. Those are both based in Jingdezhen in China. And they will take the rest of the company. And Roland is only going to have 5%. The idea of this ceramics binder jet technology, so again, I would not have primarily expected Roland DG to go with binder jet ceramics or binder jet, and then I would not have expected them to open up with ceramics binder jet. And then the focus of this is going to be on pottery. So if they're going to do ceramics binder jet, I would have expected them to do technical ceramics, for example. Instead of that, they're going to be focusing on actual pottery, like your plates and art items and all these kind of things. So it's on many levels a really unexpected move. And again, if they were going to do all this, I would have expected them to do it themselves and make it in Japan. I wouldn't necessarily expect them to make a JV solely focused on China. It could be a very exciting thing for them to, by the way, to make a Chinese-focused JG or JV, which could benefit from a lot of government support and also could play well in China and to later on commercialize this technology for the rest of the world by themselves. This could be a good strategy for a lot of markets. The Chinese market is now a bit denied. This could be a way for them to get around it. But again, very super surprising this to me personally. And they're hoping to make molds and other shapes. They're hoping to make an automated way to make pottery and other kind of shapes as well. And they're hoping to really automate the production of pottery or certain pottery items using these ceramics 3D printers. And this is, yeah, I don't know. I did not expect this at all. And I don't know what to think of this at the moment. It could be quite smart if they're doing it just for this one market and then commercializing the technology for the rest of the world differently. Otherwise, I don't know what they're doing here, to be perfectly honest with you. But it's a notable move anyway. I think it really surprised me. It's really a food for thought kind of thing, for me at least, and hopefully for you as well. I hope you enjoyed this today. I hope it was useful to you and informative. And my name's Aerospace, and this is another version of 3D printing news Unpeeled. Have a great day and enjoy your day.